Hi, my name is Ikenna Knaiwu, and today I'll be talking about AI APIs, taming the Wild West with AI gateways. Just a brief introduction to myself. I'm an independent API consultant. I am the author of the book, Automating API Delivery, API Ops with OpenAPI, which you can see on your screen, and you can get that from Manning. It's published by Manning, and it's available on Amazon. What I do is, as an independent API consultant, I help organizations improve their API governance using my toolkit. I help them improve and handle things like API sprawl, API drift, API consistency issues, and high API delivery lead times. Today, I'll be talking about API consumption governance. Usually organizations talk a lot about API governance, and when they talk about that, they mean API provider governance. So they are governing their APIs from the perspective of the APIs they produce, their platform APIs, making sure that they're secure, that they are controlled, that they are consistent, that they are high quality. And while that's so true for the APIs organizations produce, with the rise of AI, generative AI, it's important to also look at the AIs that the organization is consuming and making sure that all those good practices learned on the provider side are also applied at the consumption side. And so this talk today will be focused on API consumption, governing API consumption. So following on from that, just to talk about the kind of agenda that I'll be looking at today, which is on as you can see on your screen, it involves, number one, laying some foundations. So I'll start by talking about what I call some foundational concepts of API governance, and then I'll go on to talk about the risk question regarding the consumption of LLM APIs. I'll go on to talk about about 3 risks that we need to think about when consuming AI APIs, the first of which is security risk. And then I'll talk about the second, which is financial risk. I'll talk about the third, which is risks around data privacy and compliance. And then I'll summarize. So that's the broad agenda for this talk. Given that agenda, let's start from the very first one, which is about foundations, some foundations around API governance and generative AI applications. So in that, one of the first questions is asked is, what is API governance? Well, API governance is about establishing a framework containing strategy, policy, standards, guidelines to manage the creation and operation of APIs within an organization. You know, it's about making sure, like I said, that those APIs are consistent, are secure, they are consistent, they follow the standards that we define, they are reusable, aligned, and all those great things. So that's what we talk about when we talk about governance. And that's particularly applicable for API platform teams that are responsible for managing APIs in the platform APIs in the enterprise. Then I'll talk about AI applications, and here I'm talking about, when I talk about API management, and here I'm talking about the practical implementation and enforcement, and day-to-day operation of APIs as defined, by the governance policies. And then finally, I'll just quickly touch on now about AI applications, where here we're talking about software solutions that kind of leverage artificial intelligence techniques, machine learning, natural language processing, large language models, those kind of things, to perform tasks that typically require human intelligence. Okay, so I've defined, API governance, API management, and what AI applications are. And then I'll go on to say that we're seeing the rise of AI applications, of course, and those applications are usually used for things like conversational AI, chatbots, content generation, code generation, translation, data analysis, summarization, those kind of things. And we're seeing organizations do more and more of this within the enterprise. And as they do this, they're using more than one model. So typically they're using models, AI models from different providers. They may have their own internal models they use for some of these applications. And because of that multimodal approach, they need a way to control access and to manage the use of those models, again, to make sure that they're done in a secure, controlled way. As they do that, let's talk about let's talk about the architecture of these generative AI applications. You can consider a really simple architecture where you have some chat application that's accessing an AI model. In this case, let's take, for example, OpenAI. So imagine that kind of simple solution. At its very simplest, right? You would have the chat application talking directly to OpenAI. What I do want to point out from there is, now you wouldn't typically do this, but if you do imagine this kind of simple application, you would notice that OpenAI has several APIs to access their models, right? They have you can access them just via HTTP calls. They provide an SDK, different SDK APIs to access it, some like in JavaScript, Python and Go. And then they have different APIs. They have their responses API, they have chat completions API, their real-time API. They have several APIs you could use to access any one of their models. So that's something to keep in mind there. But of course, in the enterprise, when running production AI applications, you wouldn't generally just go out to some third-party provider like OpenAI directly. Usually, you would have, when building applications like this, you would have some sort of API gateway, and usually you will, for AI applications, it would have some AI gateway features, and I'll talk about this a bit later. So you would have some sort of front door API gateway that would take traffic from some applications or user consuming applications. There would be some middle kind of back-end AI service that does orchestration and processing. And then there would be, you would want to have some gateway, some outbound gateway, some kind of proxy between your platform and any AI models, whether those are external models or maybe even in-house models. You would need some API/AI gateway in the middle. So this gives you maybe a simple diagram of what an AI architecture around an AI application can look like. And what I do want to point out here are the gateways. So do take special note of the API/AI gateway, as I'll call it for now, but at the front and fronting those AI applications. And again, this is to give you some way to control access to those models. If we dive into that AI gateway pattern, right, what is this AI gateway? So really, we're talking about a proxy that controls traffic to those AI models, and it can contains things like, access control and credential management. It can have guardrails to manage the traffic going in and out of those AI models. It might have things around semantic caching to be able to manage the cost or reduce the cost of accessing those models. It may have cost control features to give you visibility of cost and help you optimize costs in accessing those models. It might have some routing and load balancing features. Perhaps you want to route different requests between different models. It will have features like this. So there are a set of features that you would want in a gateway or some sort of proxy to your AI models. You wouldn't just want to access them directly. And the AI gateway helps you manage that traffic and centralize those features in one place. A lot of technology vendors are providing AI gateways or AI gateway features in their API gateway. Here's a list of technology providers that provide some kind of AI gateway. So it is getting quite popular. So having given you this introduction to generative AI applications, really having introduced the concept of API governance, talked of what generative AI applications are, and talked about what an AI gateway is and what features it has. Let's move on to, having laid those foundations, let's move on to talk about AI model APIs, okay? And when we look at that, we're going to talk about what I call the risk question in this section. So what are the risks of integrating with AI model APIs? That should, from a governance perspective, from an API platform perspective, that should be top of mind for anyone who is building out a generative AI application that is going to be consuming or using sending traffic to an AI model. So there are a bunch of frameworks that are out there to help people think about the risks of consuming AI APIs. And the first one I want to talk about is the Google Secure AI Framework. It's a framework out there, of course, put out by Google to help organizations think about those risks. And there are several levels of those risks. There are risks to do with model creation, which I wouldn't go into in this talk. So risks around making sure the provenance of the data that goes into training the model and things like that are correct. So there are risks around AI model creation, which I won't go into, but I'm going to focus more about model usage. Okay, what are the risks in using AI models? And this framework does talk about what those risks are. Examples like prompt injection, which is about prompt injection is about causing a model to execute commands that have been injected, using user prompts. Using prompts, for example, you can have a jailbreak attack where an attacker can cause the model to behave in ways that they've been trained to avoid, Or you can have denial of service or denial of ML service attacks, as the Google SAIF framework terms them, reducing the availability of the service, of the system. Sensitive data disclosure, where we're disclosing private or confidential data through querying the model. Insecure model output, where the output of the model is not appropriately validated or formatted, where it can be unsafe. And then rogue actions, where there's some sort of unintended actions executed by agents, model-based agents via extensions or other accidental or malicious actions to make the the application or the model do something that we didn't intend it to do. So the SIF framework really helps people think about those risks. But that's not the only risk framework there. Another one to think about is the OWASP top 10 list of LLM and Gen AI risks. OWASP regularly publishes risks. They have their top 10 API risks. This is something for AI applications, and they do list many risks, including some of the ones we've mentioned before: prompt injection, sensitive information disclosure, system prompt leakage, and so on. So to really get an idea of the risks you can face when consuming AI model APIs, these frameworks give you a good overview, and you can look them up. I'm going to move on now to having made it clear that there are risks to consuming AI APIs. I want to go on to talk about 3 of those risks. And the first one is the security risk. And what do I mean by that? Well, there's several security risks around consuming that, but the one I want to focus on today is about API key exposure. Okay, API key exposure, and the key question there is, or the key, I guess, statement is, if API keys aren't securely stored and managed, they can be leaked, right? API keys can be leaked. Of course, this can happen with any API key, but we're taking specific focus on the API keys of AI models, okay? And many AI model APIs are exposed, especially third-party ones like OpenAI, Anthropic, and so on. They are made available via API keys. API keys are one of the most common ways to access them. And so we need to consider that risk. Here's a real-world example where where attackers were stealing API keys that have been checked into GitHub, as OpenAI API keys that had been checked into GitHub. This was from way back in 2023. And they were getting these keys and distributing them on public forums, so anyone could use those keys and access those OpenAI accounts and basically have free paid access to OpenAI. So this can happen, and you can imagine the cost implications of such an attack. And so from that, we can define a policy for ourselves in terms of governance. We can define a policy to say that Gen AI applications must route traffic via an AI gateway and use generative AI virtual API keys. What does that mean? It means that when we route traffic through the AI gateway, that would really store our API keys, the API keys to access the AI model, but we can give away sub keys, if you like, virtual API keys to applications that want to consume that traffic and do that through the API gateway. And that way we have more control. Not everyone needs to know our OpenAI key or our Anthropic API key, and we can rotate that at whatever cadence we want, and then we can have different sub keys that different applications can use. Using that kind of pattern gives us a few benefits. Number one, it's easier to rotate keys on different cadence if we want. We can use separate keys for different purposes. We can set application level limits based on API keys, and it just gives us more flexibility then on how to secure our access to the AI model. I've created a bit of a framework I use to think about the management and security of AI API consumption, and this is something I call the IGT AI model. But here, this is what you can see on your screen is this model or canvas to do with, there are two main boxes at the moment. The first box is to do with model API security, privacy, and compliance. And when we're thinking about API security, privacy, and compliance for model AI API consumption, there are a few boxes there we want to think about. You know, I talked about their credential management, input and output guardrails, prompt decoration, model isolation, authentication and authorization, and then security optimized model selection. So there are a few things to talk about. I'm not going to talk about all of them in this talk, but I'll just focus on one, which is credential management. How do we store our API provider secrets in one secure encrypted location? And like I've said before, the way to do this is an AI gateway. Okay, you can store, for example, in this example, you can store your OpenAI API key right there in your AI gateway. And then you can have applications that want to access OpenAI go through your AI gateway and use a virtual key instead. Okay, and this would let them get all the benefits that we've talked about previously. So this is a simple way that an AI gateway can help you manage the security risk around accessing a model. And whether that model is external, like an OpenAI model, or whether it's internal in your organization, your own isolated OpenAI model instance, or some custom built model you have, it's still useful to have credential management isolated in one central point that an API platform team can manage. And that central point usually should be that AI gateway. So here the AI gateway pattern can help. And just to make this example more concrete, here is what it looks like. You can make a request, say this is an AI gateway, and you're making a request to the to some sort of completions endpoint. All you need to do is it's just similar to making the request directly to the model, but this time you are providing your virtual key for your virtual key, not your AI model key. And you send your request as usual. You send the request body as usual, and it should just go through the AI gateway before hitting the model. Here's an example in a particular, just to make this more concrete, this here is an example in a particular open source AI gateway. I'm not affiliated with this provider, but just to show you that AI gateways provide a screen for which you can create your virtual keys that are associated with an AI provider key. So the recommendation from there is that rather than storing your provider API secrets with each application, you would want to store it centrally in a secure gateway and then provide virtual keys to applications. So I'll move on quickly to the second risk, which is about financial risk. Okay. And the financial risk there is around uncontrolled costs. So the question to ask there is, well, no question again, but statement, is that unexpectedly high invoices can come up. Budget overruns can occur when we do not control access to AI models. Now, obviously, especially if they're third-party AI models, the access to them may come at a cost, and this cost can rack up, okay? Especially if we have a production application that is facing high traffic. Here's an example I took from a blog post by Chris Mann in the first quarter of 2024, and this was an example of a CTO of a company who was spending about $100,000 a month, whose costs for accessing an AI model went just skyrocketed to about $100,000 a month because of lots of business was coming in. But again, given the size of his company, that was a lot to be spending on those models. And if you don't, and in this case, they didn't really have any way of capping those costs. So those costs kind of went up unexpectedly. They didn't have as much visibility into that when that was happening. So it's something where the organization had a cost shock on how much it was costing them to access AI models. So those are kind of financial risks to be aware of. And just to quickly mention, there are a few models out there as well to help organizations think about the cost of AI models. Here is the Google total TCO, total cost of ownership of AI models model. And as you can see from this diagram, there are different costs associated with AI models. So for the purposes of this talk, I'm only interested in the very top cost on the right hand side of that screen, which is the OOTB model. TCO, so model serving costs. Really, I'm only interested in model serving costs, not about all the other costs around operation of the model or defining the model or gathering data or cloud hosting costs for the model, tuning costs. Not interested in that. Just when we're talking about cost management, cost optimization, it's about the cost of consuming that kind of model. So the other thing to consider as well when talking of that cost optimization is FinOps principles. The FinOps framework, you can Google for that. It provides a set of principles organizations need to think about when serving, the applications, platforms or systems. And it's about making sure teams take ownership of their technology usage, take ownership of the costs, the operational costs, making sure the cost data is accessible, timely, accurate, and available for everyone so that it can be monitored and teams can optimize the operations, make the operations more efficient based on those costs. So these principles really give a guide on how important it is to make sure that we are surfacing and making available to teams, giving them visibility of those costs so that they can better optimize and manage it and prevent these kind of cost shocks that might arise when we give people access to, or applications have access to, AI models. And so in terms of that optimization, we need to, here's my IGT AI kind of a framework or model that I used to think about those costs. There are different costs we need to think about here, budgeting or different ways of optimizing serving costs here: token minimization, semantic caching, providing centralized cost dashboards, providing batching requests together, providing conditional routing. There's so many things to think about. I just want to focus on budgeting and token-based limiting. And how do we do this? First of all, we need to ask the question, do we need to set budget limits on how people can access AI gateways, and setting those budget limits on those virtual keys that we talked about? If we do that, there are several controls we want to think about. We want to think about what's the maximum cost budget overall we're prepared to spend in a given time window. or we can also think of what's the maximum token limit that different applications have. What's the budget reset frequency? Is it every week or every month? Or are there any thresholds, alerting thresholds we want to be aware when costs hit setting limit? So we want to be, these are things we need to think about in terms of budget controls. And also, we want to also talk about dashboards. This is the second bit of my model that I want to talk about. We want to talk about dashboards. Do we provide centralized dashboards that teams can use to access that FinOps data regarding AI model usage? Okay. And what do these dashboards look like? So here's an example from an open source AI gateway. Again, not affiliated with this, particular provider, but this is an example of what an AI of what a cost dashboard can look like for an AI model. Okay, it's easy to see what the daily spend is and what the tokens being consumed are. This is another AI gateway provider. Again, not affiliated with this, but you can see again how their charts look like in terms of cost, token use, latency. They provide a good view of costs, and this can be down to the whether it's a total or down to specific applications or users. So recommendation here is about setting budget limits, and those budget limits are cost dashboards to make sure that those controls are in operation. Very quickly, moving on to the last one is about privacy and compliance risk. And the specific risk I'm going to focus on here is about sensitive data exposure, reputation, and ethical risks. Okay, so it is possible that when we use AI models, we can inadvertently allow personally identifiable information to leak into third-party LLM providers. And then we need to talk about, this might be against the data residency issues that we need to comply with. The other thing is that we need to also guard against any harmful output from the AI model that is due to a hallucination or some other unexpected behavior or inappropriate behavior that can harm the organization's reputation. Okay, so these are some of those risks we need to think about when we think about privacy and the output of the AI of the model. Here's a real world example. This was from, again, I think 2023, where someone actually committed suicide. Unfortunately, very, very sad story of someone who took their own life because an AI model actually was suggesting that they harm themselves. The AI model was suggesting they harm themselves. So this AI model was this chat application. This chat application was giving harmful output that that affected this user. Okay. So this is an example of where we need to guard against. We need to put controls around the output from the AI models. I won't go through this whole model. I've talked about this before, but the key thing to focus on here are the guardrails, the input and output guardrails, which are things that help us verify the inputs to the AI model and the outputs to make sure that they comply with specified checks, whether it's things like off-topic detection, trade secret leakage, prompt injection prevention, profanity prevention, mitigating hallucinations, making sure we are checking that it's not sending any proprietary code into those models or things like that. So having this kind of guardrails is so helpful. There are different third-party providers of guardrails. You can look at a few on my slide here: Aporia, Lakera, Bedrock, Azure provides content safety. So there are quite a few providers of guardrails. And again, here's a quick example of how the guardrail works. Once we configure a guardrail, providing and specify what the guardrail is, in this case is for PII detection. When we do send a prompt with personally identifiable information, in this case a name, my name is Ben Smith, we will get an error. The gateway, the guardrail will intervene in the gateway and block that request. Okay, there are different kinds of guardrails, like I've mentioned, off-topic detection. There's trade secret leakage. We can do that to make sure we're not giving information into the model or leaking that. So there's different kinds of guardrails, and the recommendation from that will be to use these guardrails in a centralized AI gateway to reduce data privacy and compliance risk. So I'm going to quickly summarize to say Generative AI use cases continue to drive the need to build AI applications, and AI gateways are an important way to manage access to those models. In those AI gateways, we can implement policies like making sure we store our AI model provider API keys in the gateway, and making sure we set budget limits via virtual API keys, and we can use guardrails in that gateway to reduce data privacy breaches. Do connect with me on LinkedIn and on newsletter. I'm doing kind of a research study on governing AI API. So if you do want to find out more about this, do sign up for my newsletter and you get much information about it. So thank you very much for listening to this talk.